Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Bridging Between Algebra and Calculus series and concerns finding equations of straight lines. This study guide describes how to find the equation of a straight line for various given situations in both mathematics and experiments. Introduction. Many situations in mathematics, science and economics can be described by straight lines. In other words, they can be described by the linear model. Y equals mx plus c. This equation is explained in more detail in the study guide, What is a straight line? In the linear model, the two variables x and y are related using two numbers m and c. Specifically, m represents the gradient of the line and c is the value where the line crosses the y-axis. A common problem is, then, how do you find m and c in different situations? For example, two coordinates can be used to find the equation of the straight line which passes through them. Alternatively, if you have experimental data which lies approximately on a straight line, it is not clear which straight line to use to best describe it. There are standard statistical methods to find the best straight line to describe such data. In this study guide you will learn how to find equations of straight lines for a variety of common situations. 1. When the gradient and a point are known. You may be given the gradient m of a straight line and the coordinates of a point which it goes through. Here you only need to find c in the linear model. You can do this by substituting the coordinates you are given into the equation y equals mx plus c and solving for c. Example, find the equation of the straight line with the gradient minus 2 which goes through the point with coordinates 2, 1. Because the gradient m equals minus 2, the equation of this line is y equals minus 2x plus c. The coordinate 2, 1 is the same as saying x equals 2 and y equals 1. So, since the straight line passes through this point, the equation y equals minus 2x plus c will be true for these values of x and y. In other words, x equals 2 and y equals 1 must satisfy this equation, and so, after substituting these values into y equals minus 2x plus c, you get 1 equals minus 2 times 2 plus c. Solving this equation for c by adding 4 to each side gives c equals 5. You can use this value in y equals minus 2x plus c to write the equation of the line with gradient minus 2 which goes through the point 2, 1 as y equals minus 2x plus 5. A common example of this kind of problem is finding the tangent to a curve at a certain point. In this case, the gradient of the tangent is found by using differentiation. See the study guide, What is differentiation? And the point can be used to find c. 2. When two points are known. Any 2 points define a straight line. Therefore, given any 2 points, you can calculate the gradient m and the y-intercept c of the straight line that passes through them. First, you calculate the gradient m. You can do this by using the definition that the gradient of a straight line is the change in y divided by the change in x. The study guide, What is a straight line, has a more in-depth explanation of this. In this case, if you can define your 2 points as x1, y1 and x2, y2, the change in y is y2 minus y1, which is sometimes written as delta y, and the change in x is x2 minus x1, which is sometimes written as delta x. In order to calculate m, you divide the change in y by the change in x. M equals delta y over delta x, which is the change in y over the change in x, which equals y2 minus y1 divided by x2 minus x1. You may find it easier to remember the gradient as being the rise over the run, where the change in y is the rise and the change in x is the run. You may also find that a rough sketch of the points and line is extremely useful. Then you follow the procedure from section 1 to find c by using the gradient and either of the points you are given. You will get the same answer regardless of which point you choose. Example: find the equation of the straight line which passes through the points 1, 5 and 2, 2. Given 2 points, you can always calculate the gradient m of the straight line that passes through them. Let's make a quick sketch. Here are the axes. The first point is 1, 5, which is the same as saying x1 equals 1 and y1 equals 5. The second point is 2, 2, giving x2 equals 2 and y2 equals 2. Here is the line. Here are the points. So the change in y is delta y, which equals y2 minus y1, which equals minus 3. And the change in x is delta x equals x2 minus x1, which equals 1. So, using the formula above, m equals the change in y over the change in x, or delta y over delta x, which equals y2 minus y1 divided by x2 minus x1, which equals minus 3 divided by 1, which equals minus 3. Note that the slope of the graph is downhill as the gradient is negative. Substituting the value of m into the linear model y equals mx plus c gives you y equals minus 3x plus c. Now that the gradient has been found, it only remains to evaluate the y-intercept, c. This is the same situation as in the previous section, except that, instead of knowing just one point on the line, you know two, 1, 5 and 2, 2. Either one can be substituted into the equation to find c. Using 1, 5 gives x equals 1 and y equals 5. After substituting these values into y equals minus 3x plus c, you get 5, which is y, equals minus 3 multiplied by 1, which is x, plus c, giving c equals 5 plus 3, which equals 8. Using 2, 2 gives x equals 2 and y equals 2. After substituting these values into y equals minus 3x plus c, you get 2, which is y, equals minus 3 multiplied by 2, which is x, plus c, giving c equals 2 plus 6, which equals 8, which is the same result. So, either way, the equation of the straight line which passes through points 1, 5 and 2, 2 is y equals minus 3x plus 8. 3. When a curve and a point are known. Sometimes in science you are required to find the gradient of a curve at a certain point. The curve is known, perhaps from experimental data, and the rate of change or gradient is required. The method is to draw a tangent at that point of interest and use the methods described in the previous section above to find its equation. A tangent is a straight line which touches a curve at only one point and, at this point, has the same gradient as the curve. Example: find the gradient of the tangent of the curve below, here, at the point 2, 4. You should first identify the point with a cross on the curve. Then, place your ruler on that point and angle it so that it only touches the curve at one point, and draw this line. This is the dotted line. Then take any 2 points on this line, such as 1, 0 and 4, 12, which are marked with crosses. Then, as in the previous section, the gradient is found by using the change in y over the change in x. Here, the first point is 1, 0. And so, x1 equals 1 and y1 equals 0. The second point is 4, 12. giving x2 equals 4 and y2 equals 12. Using these values, the change in y is delta y equals y2 minus y1, which equals 12, and the change in x is delta x equals x2 minus x1, which equals 3. So, m equals y2 minus y1 divided by x2 minus x1, which equals 12 minus 0 divided by 4 minus 1, which equals 12 divided by 3, which equals 4. As the gradient of the straight line is 4, the gradient of the curve at the point 2, 4 is also 4. 4. When a perpendicular line and a point are known. If the gradient of a line is known, then the gradient of any line perpendicular at right angles to that line is found by using the formula m1 multiplied by m2 equals minus 1, where m1 is the gradient of the first line and m2 is the gradient of the perpendicular line. Example: find the equation of the straight line which goes through the point 5, 2 and is perpendicular to the line y equals 7 minus 5x. The gradient m1 of the first line is minus 5, and so the gradient m2 of any line perpendicular to this line is given by minus 5 multiplied by m2 equals minus 1. Dividing both sides by minus 5 gives m2 equals a fifth. Using this in the linear model means that the equation of the line you are trying to find is y equals x divided by 5 plus c. Now the gradient is known and also a point, 5, 2, has been given. You can use the technique from section 1 to find the equation of the straight line. You substitute x equals 5 and y equals 2 into y equals x divided by 5 plus c and solve the resulting equation for c to find c equals 3. So the equation of the straight line which goes through the point 5, 2 and is perpendicular to the line y equals 7 minus 5x is y equals x divided by 5 plus 3. 5. Given experimental results or statistical data. Often the linear model is applied to experimental data, such as this. Here, the dependent or measured variable y and the independent controlled variable x are related by the equation y equals mx plus c, where m and c are constants that must be found. Often, letters other than x, y, m and c are used, but the mathematics can still be applied. A simple method is to plot data points on a graph and draw a line of best fit by hand, making sure that approximately half the points are above and half below the line. Then the equation of this line can be estimated by taking 2 points on it, and m and c can be calculated using the methods described earlier in this guide. A more formal statistical procedure for accomplishing this is called linear regression, and you can talk to a learning enhancement tutor if you want to learn more. 6. Given exponential-like experimental data. You may suspect that your data is not linearly related, and it would be preferable to fit an exponential curve to it. See the study guide, Exponential Functions. The exponential function is y equals a multiplied by e to the power kx. As with fitting a straight line, the two numbers a and k must be found in order to fully describe the relationship between y and x. However, it is not so easy to draw and estimate these. In order to do this, the data is transformed using logarithms, and this procedure is described in the study guide, Laws of Logarithms. Plotting the data gives an exponential curve like this. By plotting the logarithm of y on the vertical axis instead of y, you get a straight line. Once this transformation has been done, the data will be approximately linear, as you can see, and the techniques described in the previous section can be applied. Further guidance and information. If you have any further questions about mathematical skills or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.